Hello everyone, I'm Helen Zhang from Google SRE. As SREs, we care about service reliability. We have a dream. We want to see the big picture of service reliability, gain insights from this data, and take actions. In the next 20 minutes, we're going to talk about how we make the dream come true. First, let's look at the problem. How many of you have seen our dashboard for SLO compliance similar to this? Some of you. This dashboard is very useful to look at error budget and aggregated SLO compliance data. The example over here, you can see the daily or quarterly aggregated data for SLO compliance. So what's the problem? We have a very useful dashboard for SLO compliance alone. However, we don't have our one-stop tool to correlate the SLO metrics with other production data. For example, we want to find out what launches or production rollout events have triggered outages, have caused SLO violations, and generated customer support ticket. After finding out the correlation, we want to take the next step to figure out what actions we can take to solve business problems. Going one step further, we also want to apply machine learning to predict SLO violation events. We have a plan to achieve the dream. We built our multi-dimensional data cube. Each cube represents our production entity. It can be either a product, a service, or a project. And each dimension represents one aspect of the production metrics. For example, SLO compliance, outage count, or SRE pager load. Then, when we want to understand the big picture of a unified view of the reliability metrics, we can just query the data cube. This high-level architecture diagram shows we have a number of disjoint data sources. They have data about production launches, postmortems, production event logging, SL reporting, cloud customer support cases, and SRE pager data. We bring all these disjoint data sources together and correlate their data source using our unique identifier. Ingest all this data into our data processing engine to create a multi-dimensional view with all this data. Create a new database. Then, when the time comes to understand the big picture of the correlations of this data source, users can create customized dashboards backed by their generated database. For the machine learning aspect of predicting SL violation, we took the very first step. However, we encountered some fundamental challenges. Number one, it is challenging to predict rare events. Number two, their data quantity and quality are fairly limited. We're not currently pursuing this path. However, we would like to pursue it further in the future. The next following slides are focusing on the first problem, unified reporting. There are 2 steps we took to solve this problem. Number 1, we need to correlate all these data sources together. We need our unique identifier across all the data sources. That is the production taxonomy we created. Number 2 is to index all the different data sources using the common identifier so that we can bring the data together and combine them to generate useful insights. From the perspective of data flow, here is a diagram showing the life of a data set. This diagram shows that all the different data sources can independently export data, and then all the source tables are being extracted so that useful data, interesting data are combined together to generate a set of base tables. After these base tables are brought together, we run the data engine to combine the different data sources, correlate all of them using the unique identifier to create the derived tables. These derived tables are used by the different teams, different use cases to display the business insights they need. From a user perspective, it's a one-stop journey. The only thing they need is to create user queries and display them in a dashboard by querying their materialized tables. That is the derived tables we described in the earlier diagram. If you look at this diagram and look at it from bottom up, we start from the source tables where the different data sources come from. And then we transform the source tables into base tables with the data we're interested in. And then do a database join from these base tables to generate the final materialized tables. These tables are queried by the end user. We kept 2 design principles during this project. From the get-go, we understand the success of this project depends on data, not infrastructure. So we intentionally kept the infrastructure extremely simple and focused on solving the data problem. For database modeling, we experimented 2 data modeling techniques. The first one is a traditional entity relationship data modeling. The second one is star schema, which is commonly used for data warehouse. Here is an example diagram of the entity relationship model. The entities include product group, product area, product, project, API names, and owners of the services. And the relationships among them are mostly one-to-N relationships. We also explored the star schema model. In a nutshell, star schema is our data model where you have one or multiple fact window model tables, and they reference multiple dimension tables. For our use case, we found out the entity relation model works best for us because it naturally fits how our raw data sources are organized. In addition, we found out in our data modeling, there are multiple M-to-M relationships that star schema doesn't deal with it very well. So now we have the architecture, the data flow, and the use cases. What business questions and engineering questions we want to answer from this technical solution. Number one, we want to find out, is my service SLI, SLO a good indication of customer happiness? Second, how often do customers find out problems before our own monitoring and alerting system detect them? Here's our example of our discoveries. This table lists 4 scenarios. There are 4 services. Their SLO aggregation period are quarterly. And the data engine does a correlation of different signals, and we gained insight from this correlation, and we take actions from this insight. For Service A, the quarterly SLO compliance result is good. And in this quarter, there's no major outage happened. So we conclude that SLO reflect user happiness. We don't have to do anything. For Service B, in this quarter, their SLO compliance is not, the data is not good. However, in this quarter, the service has had major outages. This is also our good correlation result, because it means our SLO clearly indicates user happiness. The action we take over here is we don't need to adjust the SLI and SLO. We need to fix the problem which has caused the outage. For Service C, we found out the SLO doesn't accurately reflect the user happiness, so we need to take the actions to adjust the SLI, SLO, and fix the root cause of the outage. For Service D, the correlation also indicate that SLI, SLO doesn't indicate user happiness, so we need to do something to adjust our SLI and SLO. We have had interesting discoveries. However, there are limitations to our results. The fundamental issue is from the data quality issue, because the data source we used, some of the data are manually input. So human errors happen, and for some other data sources, the data is sparse and incomplete. This is the number one problem of the limitation we encountered. Second, if you remember a few slides ago, I mentioned the prerequisite for correlating these data sources is the existence of our unique identifier, which is shared by all the disjoint data sources. We have the challenges we encountered over there is all the different data sources already have their identifier for their data sources. So it took our significant effort for them to adopt this unique ID so that we could then, in turn, use the ID to correlate different data sources. Both the team which worked on the unique taxonomy project and our team took significant effort to drive adoption of the unique ID. However, the progress is not as good as we would have liked to see. The second business insight and technical insight we want to gain from the data sources are, how is our monitoring and alerting system? Does it help us to detect problems before our customers? We collaborated with cloud support team and various other teams in the company to get to the data source and generated the correlation results. The data samples listed in this table shows, for example, for one major outage, outage number 1, we've found the correlated data shows that our own monitoring and alerting system detected the problem before customers reported. So in that case, our system is good. For outage number 2, the correlation shows we do need to improve our monitoring and alerting system so that we can detect our production problem much sooner than our customers do. And outage 3, the correlation result also shows for some services we need to improve the monitoring and alerting system. To summarize, we have built a very simple system and correlated data sources from a number of disjoint data sets and generated business insights which are helpful to identify technical and process gaps in our systems. However, the main challenges we have encountered are data issues. And we have realized that data is the key. The limitation for similar projects, what's important is to get clean data from the source. In order to achieve that, we need wide collaboration between all the teams who own the data to get high quality data from the beginning. And the second important learning we got is we need, in order to make such a project useful and have higher impact, it requires close collaboration. In our case, the limitation we encountered was the challenge of driving adoption of the unique identifier across different data sources owned by different teams in different organizations of the company. So by now, I hope it's obvious what I would like all of us to get as takeaways. For this data-heavy project and application, it's very important to establish our process to enforce clean data from the beginning. And what we have done really well is we didn't spend much time on the infrastructure itself. We used the simplest infrastructure, and we did our best to focus on the data. And in addition to that, although we didn't go too far with the machine learning effort to predict SLO violation probability, but that was a very good start, and we learned useful things from it. I would encourage everyone what our team learned from this is we solved a very short-term, immediate business problem, and we are also being ambitious to solve a long-term problem. Although we didn't go far, but the learning itself is very meaningful for our team. That is all, and we have a few minutes for Q&A. Any questions?
how long it takes for analyzing the data to predict the problem from SLO, right? So how long time it takes for finding the correlation of the data?
Our prototype, the first prototype, we completed it in a couple of months. And then we spend more time to make the process more automated and more scalable.
Right. So the second question is how soon that solution can detect that relation between the data sets?
We run the pipeline every 2 hours, and that is tunable. So if we want to see more near real-time data, we could, in theory, run the pipeline every 30 minutes or even shorter intervals.
Sure. Thanks.
Thank you.
Thanks for the talk. I'm wondering, like, lots of the sources you're using and logs and like tools and stuff, like they're mostly like from Google, right? So,
Yes.
You're doing the things basically lots of other like SRE teams they're thinking about, but maybe it's too complex and we don't really have the data, or maybe it's too complex to make the data pure, right? So you mentioned you're trying to make it very standardized. So I'm wondering, like, is this a project that you're aiming to make it like a Google-wide available, and what is the stage of the project?
Right. The goal of the project is to build one standardized service, which we can use for all teams. We started with GCP services. Yeah. The current state of the project is currently we're not actively working on it because of the fundamental data quality problem. As an alternative, there is a horizontal technical program where a different team is driving to make each service team to improve their SLO, to make them accurately reflect user happiness.
Does that refer to the SL-based alerting efforts?
I think it's called a customer-centric SLO.
Okay, I'll have a chat with you like offline afterwards.
Sure.
Yeah, thank you.
Yeah, happy to. Thank you.